subject. Okay, so the next slide, of which you do have in your handout, gives you a few more details about the class. Maybe one thing to comment here is that you do need to read the text. And with calculus books, perhaps you can live with just a 2-page summary of all the interesting formulas in calculus, and you can get by just with those formulas. But here, because we want to develop concepts and intuition, actually reading words as opposed to just browsing through equations does make a difference. In the beginning, the class is kind of easy. When we deal with discrete probability, that's the material until our first quiz. And some of you may get by without being too systematic about following the material, but it does get substantially harder afterwards. And I will keep restating that you do have to read the text to really understand the material. Okay, so now we can start with the real part of the lecture. Let us set the goals for today. So probability theory is a framework for dealing with uncertainty, for dealing with situations in which we have some kind of randomness. So what we want to do is, by the end of today's lecture, to give you anything that you need to know how to set up, what does it take to set up a probabilistic model, and what are the basic rules of the game for dealing with probabilistic models. So by the end of this lecture, you will have essentially recovered half of this semester's tuition, right? So we're going to talk about probabilistic models in more detail, the sample space, which is basically a description of all the things that may happen during a random experiment, and the probability law, which describes our beliefs about which outcomes are more likely to occur compared to other outcomes. Probability laws have to obey certain properties that we call the axioms of probability. So main part of today's lecture is to describe those axioms, which are the rules of the game, and consider a few really trivial examples. Okay, so let's start with our agenda.